Okay, so last class period we spent a little time on just talking about quadratics. We talked about that a quadratic written in standard form had an x squared value. If it does not have an x squared value, it is not a quadratic. Okay. We talked about that we have 5 potential ways of solving. Solving is where we want to find the answer that makes the equation true. We looked at square roots last time. Okay. And the situation, what we're going to see is that there are multiple ways of solving, and so if you can recognize the best way of solving, it just makes it a lot easier. Okay, so we're going to walk through all 5 steps, and then when you see a problem, you should be able to look at it and say, oh, this would be the easiest way to doing it. Okay? All right, so last class period we focused on the square roots. This is what we were dealing with last time. And the square roots met a certain condition. So once we actually put our quadratic in a standard form for the highest exponent down to the constant, okay, we noticed that if there was no bx term, okay, so it was just really rewritten as ax squared plus c, okay, equals 0, so when it's in this format there is no middle term, then the square root is a really fast and simple way of solving. Okay, so we looked at, okay, well I have x squared minus 4, notice here I did not have a middle term of bx, so the key is to solve for x, to find an answer for x. So this way, I don't have a bx term, so I can just literally take the 4 to the other side, so I added 4 to both sides. I had x squared equals 4. And then we learned to get rid of a square, you just take the square root of it, so I took the square root of both sides. And then when I did that, then you actually get a plus or minus answer because you can have 2 answers for a square, right? So the square root of 25 could be plus 5, the square root of 25 could be negative 5. So you have it where it could possibly be 2 answers, meaning plus 2 or negative 2 make that a true statement. Okay? So that then, either one of those, if plugged back in here, would make that true. Okay? So you're always going to have 2 solutions when you have a quadratic, because you have x squared, you can have 2 possible solutions. Okay? So then we had a couple more examples, which the same situation here. We put it in standard form, and then we solve for x. Solving for x like you normally would, take the constant to the other side, divide by the coefficient, and then take the square root and get your 2 answers. Okay? So that was last class. Okay? So again, there was no bx term. Okay? Alright, so what I'm going to do is, I'm going to be working on today on something that's kind of review, but then we're going to work one step. The review part of it is called factoring. You guys remember factoring? Okay? I found in the last couple of classes that that is something that we have forgotten or we need a little refresher on. So I'm actually going to take a step back and just do a quick factoring reminder. Okay? So if you want, you can flip over to the back side of your page. And just, if you want to write this stuff down, you can. I'm just going to kind of do a quick little factoring review, okay? Now, what I also have kind of noticed from the classes is that we all have learned factoring a different way. And I know that when I taught it first semester, I kind of taught it one way, and some students have known it different from different teachers, and that's fine. You can factor in multiple ways. So if there's a way that makes more sense to you and you want it stated that way, then just let me know. I'm going to go through one process and then I can go back another way, okay? So when we have a factoring review, let's just go ahead. I'm going to throw out, let me do an example here. Hold on. I'm going to do x squared minus 4x minus 21 equals 0. Okay? And so in solving quadratics, we need to go from the equation down to their factors. We need to find the factors for a quadratic equation. That's going to be step number 1. So kind of going back to what factoring was all about is we have talked about how you need to find, and this is what I'm used to kind of showing the students, and if you're not used to that, we'll go on another way in just a sec, where you take the values of a times c, which is negative 21, and you put b below, and you want to find factors that when I multiply together I get the negative 21, but when I add I get the negative 4. Okay? So 7 and 3 is a combination that will give me a 21 value, and you can make 4. And the way to make the negative 4 the 7 has to be negative, and then that would make it a negative 21. Okay? So you're trying to find factors and multiply together, I get the top value, and when I add together, I get the middle value. Okay? And then because the coefficient is 1, okay, I can actually take this middle term and I can rewrite it as the factors. So I can say x minus 7, and I can say x plus 3, and I can make that equal to 0. Okay? And then, so those are my factors, right? Now, you also can, and I'm not trying to confuse anyone, I just know that we're coming from two different spots, is if I have, my factors are negative 7 and 3, so I have negative 21, and I have negative 4, I can use these middle terms and I can rewrite the middle term. I can say x squared. I can rewrite the middle term with these factors. I can say x squared minus 7x plus 3x minus 21, and I can rewrite the middle term using those. And then I can divide it into 2, and then pull out my greatest common factors. So I would make that x, and I would have x minus 7. Over here, I would pull out a 3, and I would have an x minus 7. I would combine my similar factors, so x minus 7 becomes 1, and then x plus 3 becomes 1. Okay? If you notice, they're the same. Okay? So I just wanted to show both ways because I know, like I said, there's two different ways that people have done this before. So that is the one, that's to show you that you can get to the factors both ways. Okay? Okay, so that's a little review on that part. Okay? Questions on that? Okay? So we're going to be using this concept then on the next process. This part right here, the factoring process, is something that we have done, but like I said again, because we haven't done it in a while, a lot of students were kind of getting stuck on it. So any questions in regards to that portion prior to moving on? Anybody? Good? Okay. Now in regards to how we set this up, I know, like I said, because I know we've come from different teachers, is there any other way that someone is used to seeing it that they want me to demonstrate this example that way as a reminder? Good? Okay? All right. So let's go ahead and go on. We're going to flip our page. So we just talked about the square root portion. Okay, so that was step number 1. So we're going to flip to the step number 2. Okay? So prior to moving on, what I want to do is kind of talk about some terminologies we're going to hear to make sure that we're comfortable with the words. We're working with what's called the zero power property. Okay? And what the zero power or product property means is if two things are multiplied together, so let's say I have x times y, and they equal 0. If I have two things multiplied together, one of these we know is going to equal what value? 0, right? So we know that either x could equal 0, or we know that y could equal 0, or we know what else? They both could equal 0, right? Okay, so one or the other, or both could equal 0. Okay, we don't know which one yet, but we do know that that's a fact. One of those or both of those could equal 0. Okay, and that is if, okay, that is if it equals, your equation actually equals 0. Okay, so if something equals 0, okay, you can then take this concept and solve by factoring. Okay. Because if one of them, if they equal 0, we know that one of them or both of them equal 0. So just like here, if A and B equal 0, then A could equal 0, or B could equal 0, or both can equal 0, right? Okay? So, again, for solving quadratic, we're trying to find the two solutions that make that a true statement. So because this is true, then if we have our factors, x minus 5 or x plus 6, let's say that's an example, those are factors, okay? If they equal 0, we can say that we can separate them both and say x minus 5 could equal 0, or we could say x plus 6 equals 0, right? That's kind of like the a or the x, let's say that's x and that's y, same concept, right? One of those could equal 0, or both of them could equal 0. So then we solve. So if I say, well, if x minus 5 equals 0, what would x equal in that situation? If we know x minus 5 equals 0, how do I solve for x? 5, because I just bring the 5 over, right? So if x minus 5 equals 0, solving for x, x would equal 5. All right, if x plus 6 equals 0, what would x equal? It would equal negative 6, because we're going to subtract 6 to both sides to solve for x. Okay? So what we're doing with the zero product property is we're going to find the factors of the quadratic, which is how we just showed you in the review. And then we take those factors. If we set them equal to 0, we can solve for those values. And then that way we know that one of those answers would make that a true statement. Okay? So up to this point of where you're factoring is the review part. Taking them both equal to 0 and then solving for x is the next step. Okay? And those are finding the solution. And so what am I actually saying here? Well, if you graph a quadratic, does anyone know what the graph looks like? Any guesses? It is a parabola. Okay, you guys know what a parabola is? It's a curve, right? So it could either be like a U, like that. It could be a kind of like an N, like that. Okay. So we're used to seeing linear equations. We're used to seeing where it's like x plus 5 equals y, and then we solve for it and it's a line. Instead of a line, we're going to have a curve, right? And what you found then when you actually solve for this is you're going to find where it's crossing the x-axis here. Okay? So you're solving for these answers right here. Okay? That's what you're solving for. So let's try an example. We have x plus 4 and x minus 6 equals 0. So if I just take these, I know one of these could possibly equal 0, so I'll separate them both. So I have x plus 4 equals 0, and I have x minus 6 equals 0. Okay? So what would x equal in this case? What does x equal in this case? Negative 4, so I subtract the 4 to both sides. I get x equals negative 4. And then what would x equal in this case? 6. So add 6 to both sides. So x equals 6. So in this case, if I would draw the graph, I know that it would cross the x-axis at negative 4 and positive 6. Okay? Something like that. Again, because you solve for those points. Okay? So that's what we call, that's the zero product property. Okay? That's like kind of setting up how we solve for that. Okay? Questions on that? Okay. So we're going to go in a couple more terminologies and then we'll get moving on to kind of seeing a little bit more examples. So again, the very first thing we talked about 2 days ago was the standard form, again having it in the ax squared plus bx equals plus c, okay? So we want to have that. Again, the highest exponent is 2. It will never be anything greater than 2 or less than 2, okay? So at this point, then, we have two things. We have what the quadratic function is, and we call it a parabola. We talked about that. Okay? And it will look something like this. We have a curve up or a curve down. Okay? We have what's called a quadratic equation, which is where it's actually set to 0. And when we do that, when we find our x values, what x equals, we're going to call them or refer to them as roots. And we'll show how the terminology is. You're solving for the exact same thing. Your solutions are never different, but you're actually, when it's equal to 0, you're solving for roots. Okay? Can I help you? Okay. All right, so then we have what's called the function. And the function, what is different between these two equations? What are you noticing about it? Instead of equal to 0, what does it equal? F of x. And what do we know of f of x? We call that a function, right? And when we solve for those values, the x values, we're going to just refer to those as zeros. And there is absolutely no difference in how we solve for it. It's just if you see, hey, this equal the zeros, you're actually referring to a function. If you say it's the roots, you're referring to it was actually set to 0. The process is exactly the same. It's just kind of interchangeable terminologies. Okay? All right, and then we talked about the x-intercepts being the graph. those. Okay. So that's kind of terminology. Questions on those? All right. So let's go into some examples here. We have a step process on how to do it. I'm going to add 2 above these because this is the one you want to make sure you do these first, and then that way everything below is a lot faster. So number 1, we want to make sure it's in standard form. Okay? Standard form. And what do we know standard form to be again? Okay, we know it's a is ax squared plus bx plus c. Okay, talk for you guys. Okay, that's our standard form. Okay, we may have it where we don't have a middle term, we may have it where you don't have a c term, but you always have to have an a term. That's required. Okay? All right, then we're going to do number 2, which is greatest common factor. Okay, so greatest common factor, you want to make sure you always take out anything you can take out. Questions on that? So 1 and 2 you want to do first. Always do that because that sets you up to then what you can do next. Okay? All right. Then we're going to set everything equal to 0. If it's not equal to 0, we don't move forward because we're solving for those solutions. So you want to set it equal to 0. Okay? If it's f of x, you replace it with 0. So everything is always going to be equal to 0. Okay? All right. So let's look at example number 6 here. Let's just start with that and then we'll work our way down. Okay? All right. So first of all, is number 6. Number 1, is it in standard form? Is it from the highest to the lowest? Yes. Highest exponent to the lowest? It is. So therefore, we're good. We don't have to do anything with that one. Okay? Let's look at example number 2 here. Is that one in standard form? No, it is not. How would I make it in standard form? What's that? Okay. You want to take everything that's on the right side, bring it over to the left side, make it equal to 0. So I'm going to subtract the x over on this side. I'm going to add the 6 on this side. So I bring it over to the left side. What am I left with? X squared minus 5x plus 6 equals 0. Okay, so that's standard form. How about the third example? Is that in standard form? Okay, go ahead and put in standard form real quick. Tell me what you get. Lauren, what'd you get?
4x squared plus 7x minus 2 equals 0.
Excellent. So 4x squared plus 7x minus 2 equals 0. Okay? So good on what standard form is? All right, this one I'll just rewrite. All right, at this point then, so questions on standard form. All right, so at this point we want to go to number 2, greatest common factor. Okay. Is there a greatest common factor in the 5x squared plus 7x equals 0? Tucker, do you see one? Is there something common in either one of those terms that I could pull out? Yeah, I can pull out an x, right? So if I pull out an x, what am I left with? So I pull out an x out of these two, what am I left with? 5x plus 7 equals 0. Right? Okay. Let's look at the second term. Is there a greatest common factor here? Nathaniel, do you see a greatest common factor in this one? Yes. Is there an x in all terms? No. So this one there is no greatest common factor. How about this last one? Do you see a greatest common factor in this one? No? Okay. So then that one's fine. Okay. So step 1 and step 2, you want to check all of them right away. Okay? Because then that is going to set you up for the next step. So then we go down here and it says factor the equation. So now we want to go, this is number 3, I'll put number 3 here. I want to factor the equation, which means, kind of what we just did the review, take it apart. What are the two things that you can multiply together to make it that way, right? So if I look at x and 5x plus 7, is there anything I can factor out of either of these? It's not a trick question. No, it's not. This one is actually already factored. So number 3 is factored. If you want to factor, this one's already factored, so I'll just rewrite it. Okay? Okay, so that one's already factored. At this point, I'm going to move on to number 4. Set each part equal to 0 and solve. So if you notice, if we were up here, Notice how we took each of the factors and we set them equal to 0 and then we solve for x? We're going to do the same thing in this situation, okay? So I'm going to take my x and I'm going to set it equal to 0 because that's one factor, right? And then I'll take my 5x plus 7 and I'll set it equal to 0. Okay, so that's number 4. Set to 0. Okay, and then number 5 then is solve, or number 4 is still solve. So you want to solve. So I'm going to solve. This one's already solved. X equals 0. Can't solve anymore for that, right? What would this one be? What would I do on this? 5x plus 7. Subtract the 7. Okay, so I get 5x equals negative 7. And then what does x become? X equals negative 7/5. Okay? So now I have x equals 0. I have x equals negative 7/5. How many solutions am I supposed to have for the quadratic? We said that the very first day. 2. Do I have 2 answers? I do. So now I could plug these in and say, well, does that work? So let's say I plug in 0. If I plug in 0 here, I got 5 times 0, which is 0, plus 7 times 0, which is 0. Does 0 equal 0? Yes. Okay? If I do this one, okay, I'm going to take it up here and plug it in. I'll just do the math for you really quickly. The 5s are going to, you have negative 49 over 25 times 5. And here you're going to have 7 times a negative 7 over 5. So that's actually going to cancel itself out. Yes, go ahead. Okay. So then you're going to get 0 equals 0 on that side as well. Okay. So these will cancel themselves out. Okay. Questions on that? Okay. Ready to move on? All right. So let's go ahead and look at this example here. We did the standard form. We did number 1 and we did number 2. Okay. Now let's try to work on number 3, which is factor. Okay. So I'm going to have you guys look at number 2 example here and try and factor for me. Okay, so this should be review. So go ahead and write what you think should be your factors. We have what on top here? 6, and we'll have negative 5 down there. Okay, so go ahead and look at those and see if you can find what the factors would be. Devin, turn around. Okay, so tell me what you think the factors are. So we're number 3 for factoring. Eldar, did you get one? I'm working on the factoring.
Yeah, no, on 2.
3 and 2?
Both negative.
Both negative?
Yes.
Okay. This is a tricky one, you guys, the 6 and the negative 5. A lot of students want to do 6 and negative 1. Okay? And that's not right because while you'll get a negative 5, you would get a negative 6 on top. Okay? So good catch on that. All right?
Thank you.
You're welcome. So now I can take these two terms and I can write them as my factors. I have x minus 3 and I have x minus 2. And those equal 0, right? Okay, at this point, what do? What's step number 4? What's that? Yeah, set to 0 and solve. So I do x minus 3 equals 0, and I do x minus 2 equals 0. So what does x equal? X is going to equal what on this situation? 3. And then what is x going to equal in this situation? 2. So I take them and I plug them in. Okay? And so I am going to get a 3 squared, which is 9 minus 12. So what is that? 9 minus 12 is minus 3. And then I have a 3 minus 6 that's minus 3. So minus 3 equals minus 3. Right? Here I have a 2. If I take 2 in there, it would be 2 squared is 4 minus 8, which is minus 4. And 2 minus 6 is minus 4, so minus 4 equals minus 4. You do want to check it because if you did 6 and negative 1, or negative 6 and 1, and you walk through this whole step, you think you got the answers. When you plug them in, they wouldn't work. Okay? So you want to make sure that, because you can do this part and think it's right. When you plug in your numbers, you think it finds out you're wrong, so you know that your factors are wrong. Okay, so make sure you check that. All right, I would like you guys to try this example on your own then. Try this one on your own, okay? So setting it up, I have -8, and I have 7. Factors that make a -8 and add together make 7 is going to be a 8 and a -1. Because my coefficient is not 1, I can't just make this my middle term. Okay? I have to rewrite the middle term with this. Okay? So I'm going to have 4x squared plus 8x minus x minus 2 equals 0. Okay? So I rewrite that middle term. I break it in half, and then I solve the greatest common factor out of both. So I'm going to have 4x here. I'm left with x plus 2 here. I'll take out a -1. Remember, that's my hint right here of what I want this side to be. And so I'll have x plus 2 here. And they both equal 0. So I'll combine my like factors here, the x plus 2. And I'll combine these two together with 4x minus 1 equals 0. I set them both equal to 0, so x plus 2 equals 0, x equals -2. I do 4x minus 1 equals 0, so I'm going to add the 1 to both sides and then divide by 4, so x equals 1/4. Does that make sense? Questions on that?
No.
Alright, so this right here, just kind of FYI, you guys solve for the roots. Okay, these are roots, and the reason why they're roots is because they start out equaling 0. Okay, on the next example here, you're solving for the zeros. And the reason why that is notice how there's an f of x. You do exactly the same thing. There's absolutely nothing different that you do. So if I am doing this one here, I'm just going to put it equal to 0. So this is going to become x squared minus 3x minus 40, and that's going to equal 0. Okay? And then I'm going to go through the whole factoring process. So number 1 is standard form. Number 2 is greatest common factor. Okay? So 1 and 2.
No.
I don't have any greatest common factor in that one. It's in standard form. So I go number 3, which is factoring. So I have a -40 and I have a -3. So what are factors of 40 that could give me a 3? What's that? 8 and 5. Okay. Which one needs to be negative? The 8. Alright, so I'm going to, because the coefficient is 1, I can actually just use these as my factors. So this is going to be x minus 8, and this would be x plus 5. Set that equal to 0. Okay, so here it's x minus 8 equals 0. Here is x plus 5 equals 0. X equals 8, and x equals -5. Okay, at this point, you guys, what did you actually solve? You actually solved for what we call are the x-intercepts, okay, and where it actually crosses the line, the x-axis, okay? So that's what you actually solve for. The zeros are the x-intercepts. Again, so this is my graph. I go all the way up to 8, 1, 2, 3, 4, 5, 6, 7, 8. And I go down 5, 1, 2, 3, 4, 5, and then that is the graph of something like that. This is what you actually solved, where they cross. And like this is something that you'll use a lot. I mean, you maybe not personally, but people use a lot for a lot of different things. The beginning and the end of something. Like, does anyone here do track? Does anyone do like a long jump or triple jump? Okay. So this is something like, honestly, like you would be, depending on my velocity and depending on my height, where my start is, where would my end be? Okay, and so you could actually like kind of interpret, the start to the end. Okay, if I launch a rocket, you guys are anything in science class? You guys do rockets at all?
No.
Okay.
Put in the soda bottle.
Okay, well, and that's kind of like if depending on what my velocity is at the start, and I launch and it gets to a certain height, where is it going to land, right? And so if you're trying to get like the highest rocket or the farthest rocket, these would be something that you could actually use, So just kind of throwing that out there. Okay, let's practice these two. I want you guys to try these two on your own. Okay? Again, you're solving for the roots. So notice how it says solving for the roots. So what is my end solution going to look like? It's going to look like x equals, okay? When it says solve and list the roots, that is what you're looking for. Okay? So go ahead and practice those two. Alright, so on this example here, the first one, because it's the standard form is done, the greatest common factor, there's none, so I don't need to worry about it, so I'm going to go into factoring. Okay? So I'm going to do the A times the C, so it's negative 36, and the bottom I have negative 35. Okay, so the B goes on the bottom, and the A times C goes on top. So what are factors of negative 36, and when I add together I get negative 35?
Negative 36 and 1.
Negative 36 and a positive 1. Okay? I have to rewrite this middle term because it's not a coefficient of 1. So I rewrite it as 4x squared minus 36x plus x minus 9. Okay, and that equals 0. I divide it in half and do the... And you actually, if you switch these, it doesn't matter. You'll get the exact same answer. You just pull out in a different way. In the end, you'll have the same answer. So at this point, if these are reversed, you'll still get the same answer. I'm going to bring the greatest common factor out. This one would be 4x, and I'm going to be left with x minus 9. If I pull out this one, I want it to be x minus 9, so I pull out a 1 and make it x minus 9. Okay, so x minus 9 is common in both, so I can make that 1. And this is going to be 4x plus 1. Okay, and these all equal 0. So at this point I set them equal to 0, so I have x minus 9 equals 0, so x is going to equal 9. Add the 9 to both sides. This is going to be 4x plus 1 equals 0, so I subtract the 1, divide by 4, so x equals negative 1/4. Okay? Is there anyone that got different answers? Okay? Alright, so this one here, again, standard form is done. It's in the highest to the lowest. Okay? Greatest common factor. There is nothing I can pull out. So I want to set them equal to 0. Okay? So now I need to find the factors of 42 and negative 13. 7 and 6 are them if they're both negative. Multiply together give me 42. Add together gives me negative 13. I'm going to rewrite that middle term. So 2x squared minus 7x minus 6x plus 21 equals 0. Separate them. Up here I'm going to plot an x, and I'm left with 2x minus 7. So over here I could pull out a 3. So I'll pull out a negative 3. And I'm going to do then a 2x minus 7 equals 0. So x minus 3 equals 0. And I'm going to have 2x minus 7 equals 0. Because those are my two factors. Okay? And then x equals 3. And x equals, add 7, divide by 2, 7 halves. Okay? Did I go too fast on that one? Okay? So, questions on setting it up standard form, greatest common factor, factoring, setting each to 0, solving for them. Okay? Alright, so I'm going to kind of throw up this example here for a second. So let's do I'm going to do this right here. I'm just going to write this below it. So on this one here where you had x equals 3 and you had x equals 7 divided by 2. Okay, you guys worked to those answers. So let's just talk about what we did to get those answers. So when x equals 3, what was the step prior to it? How did that work? Yeah, it was x minus 3 equals 0. Okay? On this step here, what was the step prior to x equals 7 halves? 2x equals 7. Okay, so the step prior to that was we divided by 2, so it was 2x equals 7, right? Okay, what's that? No, right now it's just 2x equals 7. Because the step, yeah, To get to x equals 7/2, we actually had 2x equals 7 first, and then what did we have? We had 2x minus 7 equals 0, right? Okay, so the step prior to this was x minus 3 equals 0, the step prior to this was 2x equals 7, and then prior to that was 2x minus 7 equals 0, right? Does that make sense? Alright, what was the step prior to these two? So before we set them both equal to 0, what was the next step, or the step before that? We had them as x minus 3, and we had as 2x minus 7, didn't we? Equals 0, right? Alright, so then what would be the step prior to that? It would be the quadratic actual equation, right? So how do we get there? We have to do the distributive property, right? So the step prior to this is where it's actually the equation. So we'll do 2x times x gives me 2x squared. X times negative 7 is negative 7x. I got 3 times 2, negative 3 times 2x is negative 6x. And then I have negative 3 times negative 7, which is negative 21, equals 0. Okay? Notice how that we're like right here now. Okay? You guys worked your way up to here. Right? So that's my middle term that I rewrote. Okay? Which is right here. And then I go to the next step then, which is combining the like terms. Right? So I'm going to combine these. It's negative 13x minus 21, and that's 2x squared equals 0. Okay? So what I wanted to demonstrate was that we have gone from the equation down to the roots, that you can actually take the roots and work your way up to the equation. Okay? The key is, and the one trick to this, is if you have a fraction, don't do this. Okay? That is not correct. You guys see why? Because remember how to get that fraction, we actually had to multiply by the 2 and then subtract the 7, okay? So don't do that. Somewhere in there in your brain, take that away. Okay? Alright, so now that you guys see that you can work backwards and forwards, I'm going to give you this example here. You have a quadratic equation with the roots of 1/2 and negative 5. What is it really asking me or telling me? That's really telling me what? Roots are x equals, right? X equals what? 1/2 here, and then x equals negative 5. So if you read this sentence, a quadratic equation with roots 1/2 and negative 5, it's really telling you those are your x values. If it said quadratic function with zeros of 1/2 and negative 5, it's the same thing. X equals 1/2, x equals negative 5. Okay? So those are the roots. Okay, does that make sense? Alright, can you go from here down to the equation then?
Yes.
Okay, so what would be the next step? What would be the next step to go? How did I get to x minus 5? What does the step before that have to be? It had to be x plus 5 equals 0, right? What did this one have to be? This one had to be 2x equals 1,
Yes.
right? And then therefore 2x minus 1 equals 0. Okay? Make sense? So now, what do these represent? They represent what? The factors. Okay? So the factors are 2x minus 1 multiplied by x plus 5. Right? Make sense? Okay? And then at that point, what would we do? You want to multiply by distribute. Okay? So you're going to have 2x times x, which is 2x squared. You have 2x times 5, which is 10x. And then negative 1 times x is negative x. And negative 1 times 5 is negative 5. And that equals 0. And then combine the like terms. And so you'll get 2x squared plus 9x minus 5 equals 0. And so therefore you got the quadratic equation based off what the roots were. Okay? That make sense? Okay, so now you can go forwards and backwards. Okay. And then our last example is just where it gives you a value of a root with an equation. So what do I know if I say -3 is a root? How could I rewrite that?
X equals -3.
Yes. That is actually saying x equals -3. If it said a 0 is -3, it's saying x is -3. So when you see the root or 0, that's really x equals something. Okay? So if I know x is -3 and I look to my equation, I have 2x squared plus kx minus 21. It wants the value of k. Because I know x, I can substitute it in through substitution and solve for k. So I would take 2, I have x, so it's -3 squared, plus k times a -3 minus 21 equals 0. Okay? So now it's only k I have to solve for. So what's -3 squared? It's positive 9. So 9 times 2. I'll rewrite the -3k as, or k -3 is -3k, and then minus 21 equals 0. So this becomes 18 minus 3k minus 21 equals 0. Okay, so all I did is take the x value, substitute it for x, and now I'm just solving for k. Okay, now I'm left here, I'll combine my constants of 18 and 21, which is -3, so it's -3k minus 3 equals 0. So what does k equal then? -1. So add 3, so I get -3k equals 3, divide by -3, so k equals -1. So -1, if I plug that in there with -3, it would equal 0 on both sides. Okay? Alright, so questions on that? Alright, so in summary, you guys, we talked about the 0 property, the fact that if anything equals 0, one of the variables, or both, could be 0. Okay, so then we can set them, once we get the factors, we can set them equal to 0, and then find what those values are. It makes a parabola. You can talk about roots or zeros depending on if it's a 0 or function, okay? But that's just meaning it's x equals. That's what you're solving for in both situations. Then the format, the steps to go through it is standard form, greatest common factor, and then you go into factoring, setting to 0, and solving, okay? Okay, one thing I want to show you to help you when you walk through this is like there's kind of a pattern. If I have, so we want it standard form first, right? Okay. We're going to have a couple of situations occur. 3 possibilities when you get it in standard form. It's going to either be where you have ax squared plus c. You're going to have ax squared plus bx, or you're going to have ax squared plus bx plus c. So you're going to have it either where there's no middle term, you're going to have it where there's no constant, or you could have it where you have all 3. Okay, so those are your 3 possibilities. Okay, and the reason why I'm mentioning it is depending on which possibility you get, you can go an easier route. So if you don't have a middle term, we learned this the last class, you do the square root process. Okay, where you just have like x squared minus 4 equals 0. You subtract the 4, or add the 4, and then take the square root. So you're going to do like x squared equals 4, take the square root of both sides, and then you get x equals plus or minus that value. Okay? Simple. Way simpler to go if you notice you don't have a middle term. If you take a greatest common factor, notice how there's no c? At this point, you guys, the greatest common factor is the way to go. Because you're going to pull out your x, and you're going to be left with just ax plus b. Okay, so then x equals 0, and then the ax plus b equals 0. Okay, and so that's just way quicker to solve than going through the whole process. Okay, and then if you have all 3, then you're going to go into your factoring. Okay, then you'll have factoring. So depending on which situation you have, it's a lot easier to find your factors. Okay? So does everyone see the difference between the three? Okay? So I just thought that was more of a visual to say, oh, if I don't have a B, I'm going to do this. If I don't have a C, I'm going to do this. And if I have all three, then I do this. I just think that helps in regards to the direction you want to go. And recognizing that problem at the beginning will save you a lot of time.